Hello everyone, today we're going to talk about Physics 253 video problem number 29.9 of week 9. In this problem, we are asked to find the magnetic field of a wire, specifically a high voltage transmission line. This problem is interesting because I feel like it kind of relates to the whole 5G is causing coronavirus issue, in that uh, people are worried about the magnetic effects of these power lines. And although, as we'll find out, there is not much of a human impact, there is definitely an aesthetic impact on our landscapes, and it is just yeah, but let's get into the problem. So I've gone ahead and drawn out what we're working with here. As we can see in the problem statement, there's a few givens. We have that the transmission line is 20 meters above the ground, and actually for high voltage transmission lines, specifically the ones that kind of look like this, we would actually see a height of around 40 meters, which is pretty disgustingly tall. Um, some even reaching up to 60 meters, which I found interesting in some research. But um, in our case, we're just saying that this top wire here is going to be the center of our loop, and the radius is going down to the ground there. So it would be 20 meters in all directions. So it'd be 40 meters in diameter, if you will. But for this problem, it's actually a pretty simple setup. So in chapter 29.4 of the book, we are introduced to the this equation right here, which is the magnetic field of a wire. And technically, this is the magnetic field of an infinite straight wire, um, which is a little bit different than what we're working with in our model. So we're going to have to make some assumptions. So typically when you see power lines like this, we do see some kind of sag in the wire. So we're just assuming that the wire is straight, and since we're not given any kind of length of the wire, this is essentially just one enormous line of high voltage transmission lines, all in a row going across the US infinitely, is what we can imagine. So in our case, we also have to define the, or I guess it's already defined, but the vacuum permittivity constant, which is going to be 4 pi times 10 to the negative 7 hertz per meter. And at this point, we are ready to go ahead and solve the problem. So in our problem, or in our solution of the problem, we're actually not going to need this potential in volts right here, kilovolts. We actually just need the radius as well as the um, amperes current. So getting into the problem, all we really have to do is just kind of plug and chug for this one. Once we have that electric field of a wire equation, it's really not too bad. So there's no unit conversion in this, but when we get to the end here, we can go ahead and simplify our answer for mastering physics, and because it will help us in the next part of the problem, we can just say that our magnetic field strength on the ground directly under the transmission line is going to be 2 microtesla, um, and then we can take the percentage here, because we're given it the Earth's magnetic field in microtesla. We can just put one on top of the other and multiply by 100, and we're left with 4%. So this is a very low impact. I have even drawn, you can't really tell, but this stick figure is actually wearing a tinfoil hat. Um, do what you want with that information. But yeah, I hope you guys found this video helpful. Thank you very much for watching and have a great rest of your week.